All right, to get into trigonometry, we're going to learn how to graph sines and cosine graphs. They're actually very simple. I have the steps down here. If you need to pause it, zoom in at any point, go ahead and do so. I use this for pre-calculus all the time. Here, to know the difference between sine and cosine is they're slightly different, and all depends on their sentence pattern because everything else is the same except how their wave is formed. Here, we have y is equal to, the book has a sine x, but later on you'll have y is equal to a sine of bx, meaning a and b are numbers. Y is equal to a sine of b of x. A for sine and cosine is your amplitude, that's what they call it. Amplitude is your minimum point and your maximum point. So you're here in this graph, our amplitude, let's say it's y equals sine x. The number in front of sine is 1, so that means it's amplitude of 1. And then to find your min and maximum, it's just the positive and negative of the same number. So it's 1 and negative 1. Now, another thing you need to know about the graphs is their periods. So every wave is one period. So this here, from here, 0 to 2 radians, remember that's 0 to 360, that is one whole wave, that is one period. Here, the period to find it is 2 radians divided by b, and b is a number in front of x. So that's if you have it or not. The pattern for sine is it starts at 0, it works your way up, 0, down, 0, up, 0, down, 0, up, 0, down, 0. So that's the sentence pattern, or the graph pattern, sorry. The graph pattern for a sine. Cosine, same thing. Number in front is the amplitude, so that's your max, your minimum point. Your cosine, so that means you have to start at a different sentence pattern. That's max, you start at the max point instead of 0. Max, 0, minimum, 0, max, 0, minimum, 0, etc. So this one starts at your max point, this one starts at 0. B is considered your period. So again, the whole wave. This wave is a cosine graph here, but then it can keep on going and keep on going. There could be multiple waves in it. Here is B of x. So it starts max 0, minimum 0. So for example 1, we're going to identify our amplitude and our period. So our amplitude is a number in front of sine every time. It's your a, your lowercase a. So if I look here, my amplitude is 3. So they have like the absolute value of 3. It's just a number in front of 3. Now, here we have our period. Our period is now our graph. Here we have to use a formula of 2 radians divided by b. B is a number in front of x. In this case, we have a 4, so it's going to be 2 radians divided by 4. 2 radians divided by 4. Think of the fraction without the radians. So 2 over 4, if you simplify that, you get 1/2. So 1/2, or radians over 2. So we don't like 1/2 radians. It's just radians over 2. So that means one whole wave is between 0 and radians over 2. If you don't remember what the radians are, radians over 2 is 90. Radians is 180. 3 radians over 4 or over 2 is 270, and this one is 360. If you really don't like the radians, you could put it in terms of degrees. To convert into degrees, radians just means 180. So it's 180 divided by 2, and that gives you your 90. Here B, we're finding our amplitude and our period. So our amplitude is the minimum and maximum point, and it's always a number in front of sine and cosine. It's 2. That one's very easy to identify. Your period, it's 2 radians divided by b. Your b is the number in front of your x. In this case, it's 2 radians divided by 3. You can't simplify that anymore. That's just your period of a wave. So now, let's go ahead and start talking about graphing these type of functions. We have to go ahead and graph them. Oh, the book has it something different where every period is 4 periods between 0 and 360. And yeah, that's good to know, but I think what I want you to focus more is finding the actual wave from this to this point there, because that's what you're going to use for graphing for all of this here. So you could put the number 4 or just put it in radian form. Well, it doesn't matter. I focus on this more. Now, let's go ahead and graph it. First, you have to find your amplitude. You graph your amplitude. So let's say here, our amplitude is 3, so we're going to have a maximum point of 3 and a minimum point of 3. Find your period, and that's a 2 radians divided by b, and that's what I had over here. Step 3, you're going to divide the period into 4 parts because every wave you'll see a wave after you divide into 4 parts. It's not like a line. If you have 3 subjects for 3 numbers for x, you'll have your whole line there. Here it's slightly different. You need to divide it into 4 parts to see that complete wave. And the last one is just graph it. Here, this is what I use to help me graph these. For sine, I know it's 0 up, 0 down, 0 up, 0 down. And for cosine, it's up, 0, down, 0. And this applies if the amplitude is positive. So later on, we'll deal with if it's negative. And if it's negative, it just means it works in the opposite direction. So let's say if it's a -1 sine x. So there's a negative sign in front of the sign. Now we have to work the opposite direction. So it's going to be 0 down, 0 up. So it's just working opposite, but you're still sticking with the zeros. Cosine, let's say a negative cosine of x. It's going to be 0, so it starts at up, it's going to be down 0, up 0. So it's just working the opposite direction. Example 3. So we're going to go step by step. The first thing we have to identify is our amplitude. Our amplitude is 3. So that means when we graph it, I'm going to do it over here. I have a graph here, it's like sideways T. 3 is your maximum point, and your minimum point is always the opposite sign. So it's going to be -3. Very easy. Next up, find your period. Your period is 2 radians divided by b. That means you'll have 2 radians divided by 1/2. B is a number in front of x. So you have 2 radians divided by 1/2. If you look here, it's a complex fraction. To get rid of complex fraction, multiply the top and bottom by 2/1 or just 2. So you'll end up with 4 radians. So it's going to be a larger wave. Now, the third step, you're going to divide your period into 4 parts. So when you divide it into 4 parts, this is what I mean. So you're going to do 1/4 times 4 radians. So it's from the period that you have. So 1/4 divided by that 2/4 or 1/2. 2/4 to simplify. 4 radians. So same period. 3/4 times 4 radians. And then 4/4 is just 1 times 4/4. And this all, when you simplify and you find it, this will give you your whole wave. It will give you each of your intervals. So in your graph, when I ask you for your homework, I do need the intervals. You can't just put random numbers. I need for it to actually make sense with this graph here. Now, we do 1/4 times 4 radians. You'll have 4 radians over 4. Think of fractions. So 1/4 times 4 radians over 1. You get 4 over 4, which is just radians. That's your first one. Next one, 1/2 times 4 radians. So 4 radians over 2. 2 can go into 4 twice. You get 2 radians. That's your second wave. 3 radians over 4. 3 times 4 is 12 over 4. 4 can go into 12 3 times 3 radians. If you notice, there's a pattern. They always develop a pattern. Last one, 4 radians. 1 times 4 is just 4 radians. And that's your last one. And then 4, graph it according to the function. Here it's a sine. For a sine, you go 0 up, 0 down. So you start at 0, you go up, 0, down, 0, and then you have this wave here. You can go on, just pull 4 more points and have it. I just need these 4 basic points, but that is a whole wave. If you notice here, it's about half the size of a normal wave. It's actually fractions in trigonometry usually means a bigger amount, so it's a lot wider than it's supposed to be. It's compressed. That's what they call it. But in this case here, you'll notice that the graph is like that. Normally, at 2 radians, it would already have its wave like this. But in this case, this wave got a lot bigger. B. I want to do a cosine one, so let me change this and make this 2 cosine 3 over 4x. So I'm going to change it just so we can see the different waves in it. Here, first thing we do, we identify the amplitude. Amplitude, 2. We have our graph here. We have 2 here, and we have a -2 here. So that's our amplitude, maximum, minimum point. 2, find our period. So that's 2 radians divided by b. So it's going to be 2 radians divided by 3 over 4. It's a fraction. Fractions Makes it more complicated, but still the same answer. Multiply the top and bottom by the reciprocal because you're trying to get rid of it, trying to get one number. So 2 radians times 4 is 8 radians over 3. Okay, we'll just keep on going from there. So we get 8 radians over 3. Now we're going to divide it into 4 parts. So 1/4 of 8 radians over 3, 1/2 of 8 radians over 3, 3/4 of 8 radians divided by 3, and then it's going to be 4/4 or 1 times 8 radians divided by 3, which automatically makes the fourth one 8 radians divided by 3. Now we go ahead and solve for each one. 1/4 times 8 radians over 3, we're simplifying it here, so we get 8 radians over 12, and that could be simplified to 2 radians over 3. That's your first point here. Now, next one. I can just simplify it from here. 2 can go to 8 to 4, so it's 4 radians over 3. 4 radians over 3. Next one, 3 and 3, they cancel out. 4 can go into 8 twice. I get 2 radians. So again, you can just do 3/4 times 8 over 3. You'll end up with 2. So you get 2 radians. And then the last one, 1 times 8 radians over 3, which is just 8 radians over 3. Last thing, go back to the waves. Cosine, you go up 0, down 0. So it's a positive 2, so we're going to go the normal direction. So up here, 0 from each point. Down from your -2, 0, and then last one is up. So when we have a wave, we have like that. Normally, for a cosine wave, if we look back to the original one, it's from 0 to 2 radians, and it has some sort of a wave here. For this, it would be like, let's say like that, to have some sort of wave. So you've seen the shift of it, it's gotten bigger. So fractions makes it more, makes it a lot bigger than the usual. So you're gonna graph the rest of them. Make sure you send it to me through PDF. Download the app. All you have to do is just scan it. It scans it for you, like taking a picture, and it sends it to me through PDF. That means I can read it, because if I can't read it, I'm not going to count it. So if you have any more questions, let me know. If you need some other apps to use, this will probably be one of the few times that you'll actually do this. I think there's one more lesson next week for tangents, and you'll have to graph it. But again, make sure you take a picture. If you need help, let me know. All right, thank you guys.